Good notes. Okay. Okay, you're live with Sa Majesty Easy World Science Channel. Today, this is actually the third live stream on this JAMB 2021. So it is very okay that you go through the questions as you have seen there before and now check your abilities. So you are live with me. What I'll do first, I'll handle these 10 questions. And then if there is anyone that happen to be online, you ask your questions, I will answer you. First of all, I'm sorry for coming late on this live stream. It's due to an unforeseen circumstance. So we go back to the questions as we see that have been shown there on the screen. We replay it again and you try to test your ability and check if you can solve some of them. So at a quick glance, see the questions. You see 21 says, which of the following metal containers can safely be used to transport mercury? Option A, copper, B, iron, aluminium, for C, D, silver. Which of the following is a strong reducing agent? You just screenshot it. Then you see 24, there is a calculation. Then 25, we move straight to 26 and 7, 26 and 27. We go 28, 29. Then you see 30. So after this, we move straight to your own questions if you have any. Okay, here, question number 1 says, first of all, let's lift it. Question number 1 is over here. Question number 1 says, which of the following metal containers can simply be used to transport mercury? Looking at the options, you have option A, copper, B is iron, and C, this is about just asking if you know what we call amalgam. Mercury forms amalgam with nearly almost all the metals. So when mercury reacts with copper, it forms amalgam. The same thing with aluminium. So the correct answer here is B. You can safely safely transport let me get another quick note. Okay, you can simply transport mercury by using iron. So mercury don't form amalgam with iron. So the correct answer is B. So when we go to question 22, which among the following is the strongest reducing agent? The option A, ethanol, B, propanol. So this is just asking you if you know the reducing ability of some of the monohydric alkanols, which will further divide into primary, secondary, and tertiary alkanols. So by looking at this, option A says ethanol, B, propan 2-ol, C, hexane 3-ol, and this says butan 2-ol. Fine. This is just knowing the correct answer should be your ability to discover which one is primary, secondary, and tertiary. So option A is actually a primary. Let me shift this here. Option A is actually a primary Okay. To minimize this, to enable me attend to it. So option A says ethanol. I'll draw the structure for you to understand it. The structure of ethanol is just C, and there is OH here, H, and the H, then H. So this shows is a primary alkanol because look at the alpha carbon. Then there is only one alkyl attached to it. There is only one alkyl attached to this alpha carbon. So one R here, you can summarize this as R. So that makes it primary. Then watch it. In the alpha carbon, there are extra attachments there. You see, we have two hydrogen atoms. So ethanol have a powerful reducing ability because of these two extra hydrogen attached to the alpha carbon. Remember, alpha carbon is the carbon that is directly attached to the that is directly attached to the principal functional group. So the principal functional group is OH. So the primary alkanols have two hydrogens attached to the alpha carbon, and that makes it a primary alkanol. Because of the two extra hydrogen, it is a powerful reducing agent. Then the other option says propan-2-ol. Let's take a look at the structure. Propan-2-ol is 1, 2, 3. That's you put the OH at carbon number 2, so that here is H, here is H, here is H, 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 and H. Then look at the alpha carbon there. Oh, sorry. Look at the alpha carbon here. So how many R's surrounds it? We have two R's, this and this. And that makes this actually a secondary alkanol. So you can see this OH and R. So this one then extra H. This one have only but one hydrogen. Therefore, primary alkanol is more reducing than secondary because secondary have only but one hydrogen attached to the alpha carbon. So primary alkanols are more reducing than secondary, and then tertiary is never even reducing because looking at the options there, hexane 3-ol is still secondary, butan 2-ol is still secondary. So the correct answer is option A. Option A is ethanol, is more and the stronger reducing agent. The reason is because it has two extra H, and this is not only restricted to ethanol, please. All primary alkanols have powerful reducing ability more than the secondary alkanols, and therefore tertiary is never reducing, and that is why they can never be oxidized to anything. Because of this, the oxidation of primary alkanols gives you alkanyls partially, but incomplete oxidation gives you carboxylic acid, that is alkanoic acid. Then oxidation of secondary alkanol, as you can see here, like propan-2-ol, gives you a propan-2-one, that is in the acetone, of course. So oxidation of secondary alkanols gives you alkanones, while that of primary gives you alkanals. Tertiary don't have any product of oxidation because it is not a reducing agent. So we now take a look at the next question. So we go to the next question. We bring it here. Number 23 is actually a calculation which says if the molar mass of an element that forms divalent positive ion is 65, calculate the electrochemical equivalent. So we minimize and go back to our normal solving notes. So but let me expand it a bit so that you can see the question as I solve it. So in this case, please, you must know first, this number 23, solution, you should be able to know what is electrochemical equivalent by definition. What is electrochemical equivalent? So electrochemical equivalent is actually the quantity of electricity required. The chemical equivalent is the quantity of electricity in coulombs of, sorry, not quantity, please, is the mass, please. Electrochemical equivalent is a mass, please. Is the mass of that element that is discharged by 1 coulomb of electricity. So whatever mass that is discharged by 1 coulomb of electricity of any element represents the electrochemical equivalent of that element. Electrochemical equivalent is a mass. So therefore, if you have the fact that you should know that 1 Faraday is actually 96,500, in other words, some people will tell you that is the mass of the element transported by the mass of the element transported actually by 1 coulomb of electricity. Then looking at the fact that we have 1 Faraday is equal to 96,500 coulombs. Now the question says the mass number is 65, of course, and it is divalent, meaning it has a charge. Let's assume that the element is X, then the charge is +2. That's the meaning, by telling you that it is what? Just watch is here, divalent positive ions, meaning that it forms +2. And then writing the half cell equation, if it is +2, it will gain 2 electrons to give you only X. Then this shows that 1E is 1 Faraday, then 2E is the same thing as 2 Faraday. It shows that it will give you X, and the X means the molar mass. From the question, the molar mass is 65, and 1 Faraday is 96,500. So we have 2 times 96,500 will give you 65. Then what is electrochemical equivalent? This is gram, of course, because that's the molar mass. Then whatever 1 coulomb, remember this is in coulomb, the quantity is in coulomb, whatever one will give is automatically the electrochemical equivalent. Then we go here to complete the solution. 2 times 96,500 is actually 193,000. So 193,000 will give you what? 65. What will 1 coulomb give you? Whatever it gives you is the answer. Now let's check the calculator department. In that aspect, what will be X? X is now equal to, you have 65 over 1,000 over 19, 3,000, of course. And by pressing that, you have that 65 over 193,000 will give you 3.37 times 10 raised to power minus 4, and that is exactly option 3.3. okay, we have 3.4 here. Okay, the closest answer, okay, yes, of course, on approximation the answer is C. So watch it here, the answer is C. That is the correct answer to that question on how to calculate it. Remember, electrochemical equivalent is denoted with Z and is a constant, and is constant not for every element, but one particular element has its own electrochemical equivalent. So invariably, they are telling us that, remember that zinc is positively charged, it is divalent, and is 65. So the electrochemical equivalent of zinc is just 3.4 times 10 to the power minus 4. Then for this exam, you are advised to also memorize the electrochemical equivalent for common elements like copper you will meet in your examination. You can watch my video here, the cheats on how to answer some questions. I gave you the summary of some of the electrochemical equivalent. So that is it. We go to the next set of questions. We are done with this. So we get this board cleaned. Okay. We have, I think the number 25 should be here. So here, 24 says, still calculation. Calculate the hydrogen ion concentration of a solution whose pH is 3. One should know these basic facts. Question 24 is what I'm handling now. Calculate the hydrogen ion concentration of a solution whose pH is 3. Then going back to our solving board, let's shift it this way. So you should know this basic formula. These formulas will help you in calculations involving pH. Remember, pH stands for potential hydrogen. The word or the term pH means potential hydrogen. So, and by so definition, pH is actually pH is equal to negative log of hydrogen ion concentration to base 10 is a fact known. Then one should also know that pOH is also negative log of hydroxy ion concentration to base 10. One should also know that pH plus pOH will give you 14. One should also know that the concentration of hydroxy ion multiplied by the concentration of hydrogen ion will give you 10 raised to the power minus 14. These are the basic facts that will help you. Then, from this fact, if pH is actually negative log of hydrogen ion concentration to base 10, it means that hydrogen ion is also equal to antilog of minus pH. So from the question, it told us that the pH is 3. So use your calculator and say that hydrogen ion is equal to antilog of minus 3. And in the calculator here we have that the answer is the answer is 1.0 times 10 1.0 times 10 raised to the power minus 3, which means 0.003. That is option C, which will give you 0.003. So this is the hydrogen ion concentration. So just note this now, that with this you can solve any question. For example, if you are given that the pH is 10, if pH is 10, if pH equal to 10, it means that pOH will automatically be 14 minus 10, which will give you 4, because of this basic statement here. So any one you like you use, which means that OH is also equal to antilog of minus pOH. So that's it for that question. We go to question 25. Remember to ask your questions if you have any. Sorry for being late in this particular live stream. So question 25 says, which of the following is, for those that will get confused, the answer to this is 0.003. Then, which of the following titrations is used to determine the hardness of water? Of course, this is not a common or a familiar question, of course. Please, hardness of water we know is actually used, it is a way to measure the presence of calcium ions, the amount of calcium ion present, and in that aspect, watch this. Iodometric titration is used mainly, is actually used for analysis, of course, but not for that of hardness of water. You can use iodometric titration to know the concentration of chlorine in a given chlorine sample, like in a hypochlorite, that's your bleach, commercial bleach, you use it to know that. Then acid-based titration, it has its own use, but you don't use it for acid. You don't use it to know hardness of water because it doesn't concern calcium ion. Neither does it concern magnesium. Then acid triazocarbonate 4 is roughly neutralization. It's not used. So the answer from my explanation is compluxometric titration. Stay subscribed and stay tuned to this channel. I will show this experiment of compluxometric titration. That's compluxometric titration or compluxometry. It's a titration whereby you need to use aerochrome black tea. It measures the amount of calcium ion present dissolved in that water by using a chelating agent to form a complex ion together with the calcium. So by the color change, when I use this particular indicators, just stay subscribed where I'll show you this type of titration. But the answer is compluxometric titration, and such indicators used are actually aerochrome black tea. And in this case, you use a chelating agent, which is actually EDTA. So EDTA and this aerochrome black tea under alkaline medium, you need to alkaline the thing with ammonia to make the reaction effective. Then after the titration, your calculation shows the percentage of calcium ion. This is also used to determine the amount of calcium in milk. So you use compleximetric titration to determine the amount of calcium and equally magnesium, or the divalent ions. So, and the common ones we find in water is usually that of calcium, which is responsible for causing hardness of water. So don't go anywhere. I'll show you this type of titration. Even ionometric titration, I have it here in this channel. Acid-based titration, I have up to 4 videos on that. So endeavor to watch any of them. Then we go to next question, which is 26 and 27. So that's it there. Question 26 says primary, secondary, and tertiary amines can be distinguished using Tolley's reagent. No, is used to distinguish alkanals from alkanones, that is aldehydes from ketones. And the Tolley's reagent is actually a mild oxidizing agent, and that is the reagent applied in silver mirror test. Then the Hisbank reagent, exactly, that is what it does. It's used to distinguish between primary, tertiary, and secondary amines. Then C, Lucas reagent is actually used to distinguish between primary, secondary, and tertiary alkanols. I taught you the first question or the second question to this particular stream asked about which one have the most powerful reducing ability. I taught you that. I show you primary, secondary, and tertiary. So by analysis, you use Lucas reagent, and the Lucas reagent is actually zinc chloride and a mixture of a concentrated hydrochloric acid. And Hisbank reagent is actually made up of benzyl sulfonyl chloride. Yes, of course. Then you mix it up. It will separate primary amines from tertiary and secondary from their separate behaviors. Then question 27. So for those that are watching, the answer is B. So now, number 27 says, which of the following processes can change alkyl benzene sulfonoate to linear alkyl benzene sulfonoate? Most of the commercial detergents we have in the market today are made based on this linear alkyl benzene sulfonoate. The abbreviation is LABS. So it was gotten from this particular one, alkyl benzene sulfonoate. By reforming, this is branched, but this is straight. So changing branched chain to straight chain is called reforming, or just changing the structure of a compound is called reforming. But cracking is all about breaking it down to a minor one. So reforming might not affect the total number of atoms, but will affect the arrangement. But cracking will break it down, affecting the molar mass entirely. So you should know that alkyl benzene sulfonoate is actually branched. Then taking it to linear alkyl benzene, that is making it straight chain, is called reforming. So changing of straight chain to branched chain is reforming. Then changing of branched chain to straight chain, or straight chain to branched chain, is also reforming. Changing of hexane to cyclohexane is reforming, even in steam reforming. So the correct answer is reforming, not thermal cracking, not catalytic, not hydrogenation either. So we now take a look at the next question. So the next question should be 28 and 29. Okay, it's over there. So question 28 says, in the polymerization of ethene to form polyethene, the initiator in the reaction is. In polymerization of ethene to form polyethene, the initiator, there is what we call initiator, the thing that will make the reaction proceed. So the initiator is not hydrogen peroxide. Hydrogen peroxide is needed in the polymerization of polyvinyl chloride, in the formation of PVC. That's in the polymerization of vinyl chloride. That is polymerization of chloroethene requires hydrogen peroxide, of course. Organic peroxide is needed for the formation of perspex. Remember perspex, otherwise known as PMMA. That is a polymethylmethacrylate. So in that polymerization, where the monomer is actually methyl 2-methylpropenoate, that is the monomer of the perspex in question. But in that case, what we require is just an organic peroxide. But in the polymerization of ethene, to get polyethene, the trace amount of oxygen is what is needed. So the answer to this question is the trace amount of oxygen. Then I say hydrogen peroxide is needed, but not as an initiator, is needed as a catalyst during the polymerization of chloroethene, that's vinyl chloride. vinyl chloride, otherwise known as chloroethene, so that when it polymerizes, it forms PVC, which we'll see in usage in common building material for ceiling and so on and so forth. So the answer is trace of oxygen. Then I say organic peroxide, like lauryl peroxide, is needed during the polymerization of methyl 2-methyl propenoate, which is the monomer of the particular polymer perspex. So here you need this as a catalyst. This one you need it. Remember, this one is not needed in the polymerization reaction. Then we take a look at 29. The purest on 29 says the purest form of amorphous carbon can be produced by treating sucrose with conc HSO4, treating pentahydrate of copper 2 tetraoxosulfate 6 with conc HSO4, heating coke to a very high temperature excluding air, then burning carbonaceous materials. First of all, which one is the purest form of amorphous carbon? The purest form of amorphous carbon is sugar charcoal. Purest form of amorphous carbon is sugar charcoal, and it is done by treating table sugar with conc HSO4. Then table sugar is also called sucrose. So looking at the option, the correct answer is A. You can watch my video here on production of sugar charcoal, of course, where I treated table sugar with conc HSO4. Is entertaining, and the black charcoal, a kind of black monster, grew out of the same sugar. The chemistry behind it is that the conc HSO4 is a dehydrating agent, and remember the formula for sucrose is actually C12H22O11. Then when you add conc H2SO4, the H2SO4 removes water, leaving behind, watch this, the H2SO4 will just concentrate in minusing this H22O11. Remember, H22O11 is following the format for water. Water is H2O. So if 2 is to 1, 22 is also is to 11. So the conc H2SO4 automatically removes the water molecule, so that what is left behind is only carbon. So in this case, you have seen that this is what we call sugar charcoal, and it is the purest form of amorphous carbon. Treating pentahydrate of copper 2 tetraoxosulfate 6 will only give you anhydrous copper 2 tetraoxosulfate 6 and not a carbon at all. There is no way you can get carbon from copper unless you do transmutation, but I don't think it's possible for copper. Then heating coke to a very high temperature excluding air. This is Acheson process. Option C is Acheson process for the manufacture of graphite. Yes, that is how graphite is made. That's for option C here. Then burning carbonaceous material will only give you soot if you don't burn it well. So the correct answer is treating sucrose with conc HSO4. And what did I say sucrose is? Table sugar, and the molecular formula is C12H22O11. It is good to remind you that you are on with Her Majesty Easy World Science channel. Please share this particular live stream and make the good thing flow. So today we will learn how to name disubstituted compounds of benzene. A disubstituted compound of benzene was one remains metal. So this is M dichlorobenzene, while this is now P dichlorobenzene, because 1,4 represents. Let's see the next example. Okay, benzene. Okay, it tells you that we have made learning sophisticated for you. So check some other videos, some other educative, powerful videos here on this channel, Her Majesty Easy World. This is an easy world of science. Please suit yourself. There are videos on biology, chemistry, DIYs, health, anatomy, biochemistry. So check the playlist and choose the one, even for your WAEC examination, post-UME, NEET for the Indians. So please, this channel is good for you. Please subscribe and share my videos. And then don't forget to give me a thumbs up for this video. Thank you for being there. Let's go back to our normal questions. So let's replace some of the questions you have answered so far. So we told you that question 21, the answer is B, iron. Then 22 is A, ethanol. 23 is C, 3.4 times 10 raised to the power minus 4. Then 24, say hydrogen ion. We got C, 0.003. Then which of the following titration is used to determine hardness of water? The answer is D, complexometric titration. Then we also consider the primary, secondary, and tertiary amines can be distinguished using B, Hessbench reagent, which I told you is benzene sulfonyl chloride. I also explained the other options. Then 27 says the answer is reforming. That's the only way that can change branch chain to straight chain. Then we also saw 28. Question 28 says that the initiator is trace amount of oxygen, very small quantity of oxygen. Then the purest form of amorphous carbon, which is actually sugar charcoal, is produced by option A, treating sucrose with conc H2SO4. Then the last question for this live stream is here. Then we'll take a look at your question. Here is saying manganese 2 ion plus water plus Xe to give you manganese 7 plus 8 molecules of hydrogen ion. Then the question is, what's the value of X? This is our redox equation, being able to balance redox equations very well. So let's go back to our solving board. Thank you for being there. Okay, the question, this one has been answered, so let's remove it from the screen. So let's clean the board. So the last but not the least question is here. So solution to this type of question, please. You have to be careful here. Your job is to sum up the number of ions in the reactant side and sum up the one in the product side. So just find out the total that is here, the total that is here, and then minus. Their difference is the answer to this X. So watch me. We have here the correct thing, because of the way the app I'm using to type these questions is not enough. Let me write it clearly for you. This is manganese 2 plus, then plus 4H2O to give you, okay, plus Xe to give you MnO4, that's manganese 7 ion, that's minus 1, plus 8 hydrogen. So in this aspect, watch it. Your job is to calculate. This is plus 2. Let's go. This charge here is plus 2. If there is any number here, I'll times it by that number exactly. But there is no number here. So what I'll just do is plus 2 times 2. It becomes, okay, here is only 1. 1 times plus 2 becomes plus 2. Then there is no charge here. There is no charge in water. So it becomes plus 0. Which means the net charge we have here is plus 2. Which means the net charge that will also be here will be 2. Then watch well, here we have minus 1. This is the charge here. Minus 1 plus 8 is giving us what? 7. So what must you do? Since you have gotten 2 here and you have gotten net charge of 7 here, simply just write the charge you got here, 2 minus 7. And 2 minus 7 is equal to 5. So, sorry, 2 minus 7 is equal to minus 5. So the answer is D, minus 5. So rule, just check the total, the net charge on one side of the equation, then minus. Let me give you another second example so that you understand what I'm saying. Let's take, for example, we have a reaction, a half equation reaction like this. We have Cr2O7, 2 minus, then plus 14H plus, then to give you here is unknown, we might call here Xe again. so that you try and find it out. So what we have here is 2Cr3 plus, then plus 7H2O. Automatically, if you are now told to find the value of X here, do exactly what I did here. Let me help you. What I did here was just how many charges are here. Here we have -2. That is -2, then plus 14. This is plus 1 times 14. So -2 plus 14 is automatically 12. Then come here and find the total charge. 2 times plus 3 is plus 6. The water is 0 charge, then plus 0. There is no charge here. So what do we have? We have 12 automatically minus what? 6, which will give you 6. So then X is a plus 6. So that's how to find this ionic equation and balance it well. The net charge on the left hand side will be equal to the net charge on the right hand side. Then if it is confusing you, remember we move from 12 to 6. Normally in life instance, for 12 to become 6, you need to minus 6. But here in redox equations, please, if 12 becomes 6, it means it has lost 6. So if you have been 0 and lose 2, you'll automatically increase to 2. This opposes normal mathematics. But if it is confusing you, use just that cheat I just said now, that simple way, that simple approach. Let me give us another example. Like if you are told, if this is ion 2 plus to become ion, here the total charge here, there will be something here plus how many E, how many electrons will be here. To find it, just say this is plus 2 here and this is 0. So 2 minus 0, because there is no charge. 2 minus 0 automatically becomes 2. But in a situation whereby we have something like this, F to give you Fa3, then Xe, find X. For you to find what X is, just find out that the charge here, the net charge here is 0, simple, and the net charge here is 3, then minus it. Always use minus, so 0 minus 3. 0 minus 3 is minus 3. So X is automatically minus 3. So that is how to do it for half cell equations. So thanks for being there. Now I'm waiting for your questions. If you have any question to ask, this is the right time to bring those questions in the live chat. Please, I'll be here to welcome your questions. For those of you that are still there online, you can see the number of you there. So ask me your questions so that I'll help you. We are done with the 10 questions I have. If you don't have any question, that means I'm ending this live stream.
My name is Sushma Tripathi and I'm a first year medical student.
We're here today to ask you to please subscribe to Sir Majesty Easy World.
It has cool experiments and it makes science fun. So, subscribe.
Please.
Then the school here, you can see is a nice school. You can enroll your ward there, Fountain Comprehensive College. You see their locations. I work with them. They are okay. It's a very nice school. They are raising a total child, of course. The completeness of a child comes from the fountain. Your child will spread like a fountain, spray all over the world for a fountain. Then Fountain, thank you for partnering with Sir Majesty Easy World Science Channel. So please bring your question back. Waiting for any questions. If I don't see any questions, I end the live stream. Please, you that is still there live, get us your questions. Your questions, your questions, your questions.
I love you. Thank you for watching. I love you. Thank you for watching.
So as we wait for your questions, let's play other past live streams. The question, I'll start from stream 1, then I go to stream 2. You see the questions there.
true. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Make it move, make it groove.
Okay, thank you for being there for today's live stream. Please, these questions for the stream 1 and stream 2, you check them here on this channel. I've answered them and explained them in details. It's nice having you. So thank you for today's live stream. Not seeing you shows that, not seeing your questions, it means that you don't have any. But please, tomorrow, Thursday, 2:30 p.m., that's GMT plus 1 time zone, Nigerian time, biology live stream comes live. Then Friday, the same time, Friday, chemistry continues. So please try to tune in and remember to share this. Your success is my topmost priority. I value you so much. Her Majesty's World Science Channel loves you so much.
I love you. Thank you for watching. And